Hi all, we are Team Codemasters and today we are here to present you our project which is wind turbine energy prediction. So this is our problem statement. Wind power forecasting plays a key role in dealing with the challenges of balancing supply and demand in electricity system, as we all knew that, given the uncertainty associated with the wind farm power output. So accurate wind power forecasting reduces the need for additional balancing energy and reserve power to integrate wind power. So for a wind farm that converts wind energy into electricity power, a real-time prediction system of the output power is significant, and this is what is our problem statement. And for this, we have proposed different solutions, and we are here to propose a solution in which we have a website developed powered by an ML model where users can predict the power by submitting the wind characteristics such as wind speed and direction. This is one way of predicting. Another way that we offer for the user is that user can also predict power output for any location by entering the latitude and longitude of the area. And in another way, the web application can also compare the output of wind turbine between two locations too. So the technology stack that we have used for these projects are, so for tools and frameworks, we have used Python, React.js, and Flask. And for the algorithms, especially for building the models, we have used SGBoost regression. And for hosting and deployment, we have used Render and Netlify.
Next up, we have the data pre-processing part, for which we have chosen a dataset from Kaggle which has the following variables: date time, active power, wind speed, theoretical power curve, and wind direction. It has about 50,530 entries, and the dependent variable here is active power. We then checked for null values and found that there are no null values, so we proceeded to exploratory data analytics and inferred that active power is more proportional to wind speed, and we know logically that theoretical power is the least important one. This is a visualization between the wind speed and wind direction. These are the kernel distribution estimation plots for the following variables, and this is a visualization between date time versus theoretical power curve. We then split the dataset into dependent and independent variables, where the dependent variable is active power and the independent variables are wind speed and wind direction. The next important step is to choose a model which provides best accuracy for the following data. We considered linear regression, random forest regressor, XGBoost regressor, and decision tree regressor for the test, and found that XGBoost provided the best R2 and root mean square error score. So we performed hyperparameter tuning on the model, which resulted in an even greater accuracy. So we finally chose XGBoost regressor for our dataset as the best fit model.
Power prediction using three different features. Firstly, it is predicted by entering the latitude and longitude of a particular location. Now the latitude is given as 11 and longitude as 77. Submit is clicked and the output received is 21.228163 as the power prediction. Next, the power is predicted by wind speed and wind direction. Wind speed is given as 7 and wind direction as 11. Submitted, the output is given as 868.29063 as the wind prediction. Next, it's between two locations. Location 1, latitude is 11, longitude is 77. Location 2, latitude is 10 and longitude is 66. Submitted, wind prediction for location 1 and location 2 as follows.
And now we come to the conclusion part. So we conclude that wind energy plays an increasing role in the supply of energy worldwide. The energy output of a wind farm is highly dependent on the weather conditions present at its site. If the output can be predicted more accurately, energy suppliers can coordinate the collaborative production of different energy sources more efficiently to avoid costly overproduction. In this project, we take a computer science perspective on energy prediction based on weather data and analyze the important parameters as well as their correlation on the energy output. To deal with the interaction of the different parameters, we use five various algorithms of machine learning. Our studies are carried out on publicly available weather and energy data from a wind farm. We report on the correlation of the different variables for the energy output. The model obtained for energy prediction gives a very reliable prediction of the energy output for supplied weather data. Thank you for watching our presentation by Team Codemasters.